Hey guys, this video is about interconverting between moles and mass. Let's say you have, for example, silver. If you had 0.0342 moles of the element silver, and you wanted to figure out how many grams that is, we start, of course, with the 0.034 moles, and we multiply by the conversion factor of grams over moles. This way, following the diagonal rule, our mole units will cancel, and we're left with grams. For the grams to mole conversion factor, that's where we have to look on the periodic table. And when you look underneath silver, when you look on the periodic table, usually the molar mass is beneath it. For example, if this were hydrogen, you see the symbol hydrogen. Usually the atomic number is written above, and the molar mass would be written underneath. However, every now and then it's reversed, or they may be in different locations. The molar mass is the uneven number. So even if a particular element has a number without any decimals for the molar mass, look at the others surrounding it. The molar mass will be the number with decimal points. So what this means is, for silver, when we look at silver, it has a molar mass of 107.9. 107.9 grams. And that's for 1 mole. That's grams per mole. When we put that number in, because it's on top of the fraction, that means we're going to be multiplying 0.0342 times 107.9. Following our rules of significant figures, these zeros are simply placeholders, which leaves us with 3 significant figures on the left, and in the molar mass there are 4 significant figures. The 0 in between non-zeros is considered significant. So we're going to round our answer down to 3 significant figures. When you multiply this out on your calculator, you should get 3.69 grams of silver to 3 significant figures. Let's try a similar problem. However, this time we're going to use something that's already given to you in grams, and we're going to figure out what that is in moles. So our next example might be, go up a little bit. Let's say you're given 25.0 grams of carbon dioxide, CO2. If we want to figure out the moles in this case, instead of using our conversion factor with grams on top and moles on bottom, it's the exact opposite as in the first problem. Notice that above, moles is on bottom and grams is on top, and we've switched the order. And this, of course, is so that we can cancel the grams unit and keep the moles. Because this is a compound, CO2, we're going to have to add up the individual masses of each of the elements. We get the number that fits in the conversion factor by adding up carbon's weight, which is 12.01, plus 2 oxygens, 2 times 16.00. When we add those numbers up, we get 44.01. Now this number is grams per mole, grams in 1 mole. Because it is grams per 1 mole, the 44.01 goes with the grams, because that's how many grams 1 mole weighs. And now because 25 is on top and 44.01 is on the bottom, we're going to divide 25 by 44.01 to get our answer. Rounded to 3 significant figures, because 25.0 has 3 significant figures. Don't forget that that 0 right there is to the right of a decimal at the end of a number, so it does count as a significant 0. And 44.01 has 4, So we round our answer to 3 significant figures, which is 0.568 moles of CO2. That is how you do mole mass conversions. A little quick review. In our first example, we are given moles and converting to grams. In our second example, we're given grams and we convert to moles. You always want to cancel following the diagonal rule the units. You get rid of the units by dividing out the unit you don't want, and the conversion factor places the unit you want to keep or convert to on top. If you follow that process, you should get the right answer every single time. One final thing to remember, when doing the molar mass, we always put the number, the value, with the grams. Notice that it's with grams on top as well as grams on bottom, because these values of molar mass are grams per 1 mole. And that is how you interconvert between moles and mass.